All right, so a lot of people really don't like graphs, but I think this is a really nice video because it sort of connects everything that we've talked about in these two sections this week. And you can visualize it and see it, okay? So we're gonna start with example 4. So graph the following. And specifically, I want you to make sure that you're noting all of the intercepts, x and y's, their multiplicities, and end behavior. So what we're going to do is just find all of those things and gradually add them to the graph. Okay? So in part A, where I give you f of x is equal to x plus 3 squared, and x minus 2. We're going to combine everything here. So first we need to find the intercepts. So the y-intercept is going to be when x is equal to 0. Right? That's going to be y is equal to, well, that's going to be 0 plus 3 squared times 0 minus 2. 3 squared is 9. 0 minus 2 is negative 2. Y-intercept is negative 18. Whereas the x-intercepts, right, are negative 3 and positive 2. The multiplicity of negative 3 is 2, because that's our exponent. The multiplicity of positive 2 is 1, because that's our exponent right there. So let's start incorporating this into a graph. All right, for the x values, let's go maybe 5 in every direction. For the y values, we can't count to 5. We need to go down to negative 18. All right, so maybe we can just count by 5. This is negative 20. 5, 10, 15, 20. All right, you can have whatever scale you want, whatever scale makes sense for these values. So our y-intercept is at negative 18, just like right there. The x-axis, or x-intercepts, where it crosses the x-axis, are negative 3 and positive 2. And specifically, let's incorporate multiplicities. Right? Multiplicity is 2, so it's either going to kind of look like a parabola here or a downwards parabola. We have to decide which way it goes. Well, it has to go down here. That's why we know it's going to look sort of like a downwards parabola right there. Because if it was an upward parabola, we'd have nowhere to go. Right, if it was upward parabola, we'd have to come all the way back down here and there'd be another 0, but there's no other zeros. Oh, we could also incorporate end behavior for knowing about this, right? What is our degree? The degree, this is going to give us an x squared. This is going to give us an x. The degree is going to be 3. Right? When you multiply this out, your biggest thing is going to be x cubed. And your leading coefficient, well, it's going to be a 1x squared from this term. And it'll be a 1x, that'll be a 1x cubed. And again, you can FOIL this out if you'd like. So since the degree is odd and the leading coefficient's positive, the end behavior kind of looks like a cubic function. So that's another way of knowing that it goes down here, because our end behavior says we're going down to the depths on the left. And we're going up forever on the right. That's what the end behavior says. We still haven't used this information. This has multiplicity 1, which means it crosses kind of like a line. So it's going to look kind of like that. And as soon as you've incorporated all this information, you just connect the dots. All right, so this connects like that. This kind of goes maybe something like that. Sure, maybe that's what it looks like. All right, and that's what you're supposed to do in these problems. All right, let's check our answer. See how good or how bad we graphed this. Okay, let's use Desmos. Our function right here is x plus 3 squared. Oh dear. Times x minus 2. And let's use the same, right? In our graph, we went from negative 5 to positive 5. We went from negative 20 to positive 20. If we have the same scale right here, it'll look more similar. And the question is, does this look like the graph that we graphed? So notice that right here, we bounced off at -3. We bounced off at -3, just like this. And then we went through on +2, just like we have. And the y-intercept is -18, just like we have. So it's a little off, right? Here, the turning point, my turning point was negative, a little negative. Their turning point, right? The positive x coordinate. So it's a little off, but it's pretty close, all right? And we incorporated all the information that the problem wanted us to incorporate. So that's how you approach these problems. We're going to do another one, though. Don't worry. All right, let's do part B. H of x is equal to x minus 1 cubed times x plus 3 squared. So we're just going to go through and find everything again. Y-intercept is when x is equal to 0. That's going to be 0 minus 1 cubed, 0 plus 3 squared. Well, -1 cubed is still -1. 3 squared is 9. Our y-intercept is going to be -9. The x-intercepts, we already have them factored, which is nice. It's going to be x is equal to +1 and -3. And the multiplicities are going to be those exponents. Right, so the multiplicity is going to be 3 and 2, respectively. So again, make our plot. We get to decide our scale. X are 3 and 2, so we don't even really care about negative numbers. We could have moved this y-axis over. Anyway, let's just go count to 4. And again, we could have negatives, but we don't really need them. The y values are, we need to at least go to -9. We could count by 5. Sure. Our y-intercept is -9, which is right there. Our x-intercept, I was looking at the multiplicities. Our x-intercepts are +1 and -3. What's our end behavior? Before we incorporate multiplicities, what's our end behavior? Well, our degree, there's going to be an x cubed from this term and an x squared from this term. Our degree is 5. X cubed times x squared, or x to the 5th. And again, our leading coefficient is just 1. Right? Because if you multiply all this out, you will get a x to the 5th. There's no numbers that are going to get multiplied by x to the 5th. So again, it's odd. Leading coefficient is positive, so we have the same end behavior as last time. Look back to the end behavior in the very first video of 3.2 if you don't remember, and 5.2 if you don't remember end behavior. So it's got to go up on the right and down on the left. Now we start incorporating information about multiplicities. This 0 right here, at -3, multiplicity is 2. So it should bounce off. Specifically, we know it's going to look like a downwards parabola because it has to connect over here. Very similar to the last problem. This 0 right here, the 0 is 1, and it has multiplicity 3. That's going to look like a cubic function. And we know it's going to go up like this because it has to connect. So, little mini parabola, little mini cubic. Now we just connect everything. Again, I don't know where this turning point is. It doesn't really matter for us yet. Just kind of connect it in a way that sort of feels right. Let's check our answer, right? So we're going to have x minus 1 cubed. I should just write this from scratch. X minus 1 cubed times x plus 3 squared. And our scale that we wrote on our paper was -4 to 4. And negative 10, well, we went below the x-axis. Let's say negative 15 to positive 10. All right, so again, we do have this, which is exactly what we wanted, right? That 0, this 0 behave just like we have, right? Kind of a cubic, kind of a parabola. Those zeros behave. Y-intercept is negative 9, just like we had. And it really goes down here, right? It goes all the way down to negative 35, our turning point. Right? And our end behavior is the same as well. Okay. We had that it goes up on the right and down on the left. And that's exactly what we have here. Up on the right, down on the left. So their function is a little bit more zoom, it goes way down than ours, but it's a pretty good sketch. That's how you do this sort of thing. All right. Taking a long time with this video just because this is a part that a lot of people struggle with. So I want to give you more examples rather than fewer. Next up, we're going to look at some problems from the book, number 48 and number 50. All right. So over here, number 48. Use the graph to write a formula for a polynomial of least degree. So we're going to use the intercepts to do this. We're going to start with the x-intercepts and their multiplicities. And then we're going to go to the y-intercept. Let's jot that down. The x-intercepts are negative 2, positive 1, and positive 3. Okay. X-intercept, x is equal to negative 2, positive 1, and positive 3. And we need multiplicity information as well. It crosses kind of like a line, crosses like a line, crosses like a diagonal line. These are all going to have multiplicity 1. We also want to look at the y-intercept. Y-intercept here is positive 3. Let's write that down as well. So let's use all this information to come up with a formula. So we'll have f of x. Well, if it has a 0 of negative 2, that means there's an x plus 2. Right? Multiplicity of 1, your exponent's 1. It also has a 0 of positive 1. It's going to be x minus 1. Multiplicity 1. Also a 0 of positive 3. That's going to be x minus 3. Multiplicity 1. So again, an exponent of 1. This is a function with the correct x-intercepts and the correct multiplicities. We just have to check, does this function have the right y-intercept? So as we've written it right now, the y-intercept is going to be 0 plus 2, 0 minus 1, 0 minus 3. As we've written it, the y-intercept is negative 2 times negative 3, which is positive 6. Our answer is not right. It's a good start, but it's not right. We have the right x-intercepts, but we have the wrong y-intercept. Our y-intercept is twice as big as it should be. Well, if it's twice as big as it should be, let's cut it in half. And now, what does our y-intercept become? Now our y-intercept is 1/2. When x is 0, we get 2, negative 1, negative 3. Now if we multiply this all together, it equals 3, which is what we wanted for our y-intercept. Right? So this should be our function right here that matches the one in the book. Let's see. Let's write this down in Desmos. Y is equal to 1/2 times x plus 2 times x minus 1 times x minus 3. And we're going from -5 to 5 in all directions here. And again, you don't have to change this right here. But if you change your scale, it'll make it a lot easier to check whether it's the same. Is this graph the same as this graph? Yeah, they look pretty close. Have the same y-intercept. They have the same x-intercepts. Have the same shape. There we go. For number 50, let's do the same thing. Okay, what are the x-intercepts? The x-intercept's here, where it crosses the x-axis, which is at x equals -1, and x is equal to +2. So x equals -1, +2, and we also want to know their multiplicities. Well, here it bounces off like a parabola. Let's say that's multiplicity 2. Here it crosses like a line, diagonal line, multiplicity 1. So multiplicities are 2 and 1 respectively. We also want to know the y-intercept. Y-intercept here is 2. So let's make a guess with the x-intercepts. We're going to start with a guess for the x-intercepts and then make sure it's the right guess by checking the y-intercept. So a 0 at -1 means it's going to be x plus 1. Multiplicity 2 means that the exponent of that factor is 2. 0 of 2 is going to be x minus 2. Multiplicity 1, the exponent's a 1. Let's check the y-intercept. If x is equal to 0, we're going to get 1 squared times -2. The y-intercept of -2, we wanted a y-intercept of +2. So this is no good. We had -2 and we wanted +2. We're just off by a negative. Let's add a negative in there. And now it'll be +2. And you could check that as well. Let's check our answer with Desmos. See if we got it right. All right, so we have negative x plus 1 squared times x minus 2. Do these things look the same? Bouncing off at -1, bouncing off at -1. Crossing at 2, crossing at 2. Y-intercept is +2. Yeah, sure, great. Look pretty similar. Last example of the video, which is very similar to the previous one. Going to be example 6. Find an equation for the polynomial of degree 4 that has a root of multiplicity 2 at x equals 4 and a root of multiplicity 1 at x is equal to 1 and x is equal to -2. Additionally, the y-intercept is 0, -3. This looks like a nightmare. It looks like a mess. But it's the same thing we've just been doing. Same exact thing. So let's write this out. F of x is equal to, all right, we have a root of multiplicity 2, a 0 of multiplicity 2 at x equals 4. So there's going to be a factor of x minus 4. But it has multiplicity 2 at this 0. Multiplicity 2 means it's going to have an exponent of 2. There's also a root of multiplicity 1 at these two places. X is equal to +1. That means there will be an x minus 1 factor. X is equal to -2. That's going to be an x plus 2 factor. And because their multiplicity is 1, the exponent is just 1. All that's left is to make sure that this has the right y-intercept. Let's check the y-intercept. When x is equal to 0, we're going to get -4 squared times -1 times +2. Right, that's 16 times -2. Oh dear, that's -32. That's not the right y-intercept at all. Okay. We wanted the y-intercept to be 3. So what do we have to multiply this by to get 3? -32 times what number is going to be -3? Because that number is what we put right here. I don't know what number that is, but I can solve for it. Especially if I don't hide it behind my head. To solve for a, you divide both sides by negative 32. A will be 3 over 32, which is a weird looking number. It makes me a little nervous. You know what I'm going to do when I'm nervous? I'm going to check my answer. So let's see, if we graph this on Desmos, let's see if this does what we want it to do. Okay. So our guess is maybe 3 over 32 times x minus 4 squared times x minus 1 times x plus 2. Let's see if this satisfies the requirements. Okay. The requirements were a root of multiplicity 2 at x equals 4. Ah, we do have a 0 at x equals 4. And it has multiplicity 2, right? It's like a parabola. It's bouncing off. That's a good sign. We said we had a root of multiplicity 1 when x is equal to positive 1 and negative 2. Positive 1 and negative 2, we do have roots of multiplicity 1. Zeros of multiplicity 1. Good. The last thing is the y-intercept was supposed to be negative 3. Hey, it crosses at negative 3. This is exactly the function we wanted to make. And that's how we do it. All right. This is a tough, this material is tough on this video, so don't hesitate to reach out if you have questions. 21 minutes, is that a record for this semester? Maybe.